All right, so now let's get to doing a few examples here using the product and the quotient rule. So here we have two um, functions being multiplied. So we're going to say f of x is equal to 4x squared plus 3. And we're going to have g of x is equal to 2x plus 5. So now we can use the product rule, that is f of x times g prime of x plus g of x multiplied by f prime of x. All right, so now we'll substitute that into that rule. So we're first going to have 4x squared plus 3 multiplied by 2x plus 5 prime plus 2x plus 5 multiplied by 4x squared plus 3 prime. Prime obviously meaning just to take the derivative. So we have 4x squared plus 3, and then the derivative of 2x plus 5 is just 2. Then multiplied by 2x plus 5, and then the derivative of 4x squared plus 3 is going to be 8x. Okay, so now we'll distribute this 2 into the two terms over here on the left side here. So we're going to have 2 times 3, which is going to be 6, plus 2 times 4x squared is going to be plus 8x squared. And then we're going to have plus 8x times 2x is going to be 16x squared. And 8x times 5 is going to be 40x. And now we'll just combine like terms. We have 2x squareds here. That is 8x squared plus 16x squared is going to give us 24x squared. And then we're going to have plus 40x and then plus 6, nothing else to combine. These are the last terms here. And this is the derivative of the original function. All right, so now we are at our second example. We have y equals e to the x plus 2 times 2e to the power of x minus 1. So our f of x is going to be equal to e to the power of x plus 2, and our g of x is going to be 2 times e to the power of x minus 1. Now we'll use our rule. We have y prime is equal to our f of x, which is e to the power of x plus 2 times 2 times e to the power of x minus 1 prime plus g of x now again to e to the power of x minus 1, and then the f prime of x, which is the derivative of the f of x, which is e to the x power plus 2. All right, so now we have y prime is equal to e to the x plus 2, and the derivative of 2e to the power of x minus 1 is just 2 times e to the power of x plus 2 times e to the power of x minus 1. And, forgot to take the derivative here. The derivative of e to the x plus 2 is just e to the x. And now we're going to drop down to y prime is equal to, now we'll distribute this to e to the power of x to the two terms over here on the left side. That's going to be 4e to the power of x, and then plus 2e to the power of 2x. Okay, and now we're going to add, again, we'll just distribute these two, or the ex to the two terms on the left here of that parentheses, and we're going to have e to the x times negative 1, which is negative e to the x, and then e to the x times 2ex, that is just 2e to the power of 2x. Now we'll get rid of the parentheses, so we have y prime is equal to 4e to the power of x plus 2e to the power of 2x minus, e to the x plus 2e to the power of 2x. Okay, now we have to combine like terms. We can see that there is 2e to the power of 2x's. That's going to be y prime is equal to 4. We're just adding them here. 4e to the power of 2x. And then 4e to the power of x minus e to the power of x is going to be plus 3 times e to the power of x. So this is your final answer of the derivative of the original function here. All right, let's do one more using the product rule. We're gonna have y, or I'm about to write yx. Y is equal to x plus 2 times the root of x, or square root of x, times e to the power of x. So here we have f of x is equal to x plus 2 times the root of x, and g of x is equal to e to the power of x. So now we'll use the power rule here. We're going to have or product rule, I should say. Y prime is equal to f of x, which is x plus 2 times the square root of x, times the derivative of e to the power of x, or we'll just write e to the power of x prime, plus, now we have to write e of x, which is just e to the power of x, times x plus 2 square root of x and prime. All right, now we just have to simplify and take the derivative. We have just x plus 2 times the square root of x, and the derivative of e to the x here is just e to the x plus e to the x, nothing to do there. And we'll take the derivative of that parenthesis here on the right. X plus 2 root of x is going to be just 1 plus, and then I'm going to do the work over here on the left side. Change the color real quick. So the derivative of, the derivative of 2 root x, we can use the constant multiple to factor out that 2. So we have the derivative, or we have 2 times the derivative of the root of x, and the root of x could be rewritten as x to the half power. So now the derivative would be 2 times half x, and half minus 1 is negative half, and this is our derivative. We multiply these two, we get 1, so we're left with just x to the power of negative half. So that's exactly what we're going to write here at the end. We're going to have x to the power of negative half. And now we've taken the derivatives, and all we need to do now is simplify. So we have y prime is equal to, we'll distribute the e to the x to every term in here in the parentheses. So we have 2ex root of x, and e to the x times x is just going to be plus x times e to the power of x. And now again, same thing, we'll distribute this e to the x to both terms over here, and we're going to have e to the power of x times 1, which is just e to the power of x, and e to the power of x times x to the power of negative half is just going to be plus e, or we can write, we'll write the x first. We'll have x e, or x to the power of negative half times e to the power of x, and this is your final answer. One thing, you could rewrite this term instead, so we'll write every single term. You could have the answer as this over here, or you could have the answer as e, or 2 times e to the power of x root x, plus x to the power of, or x times e to the power of x, plus e to the x, so many e to the x and so many x here, plus e to the power of x over the root of x. You can have it either way. Either way, it's still the same answer, but we have these two as the derivative of the original function. All right, so now let's get to the quotient rule. Now again, the quotient rule is g of x times f prime of x minus f of x times g prime of x over g of x squared. So now let's go ahead and do an example. We'll have the first example to be y is equal to x over x squared minus 1. So our f of x is going to be x, and our g of x is going to be x squared minus 1. So now we could use the rule. First things first is multiply the g of x here. So we're going to have x squared minus 1 times the derivative of x, or the prime of x, minus f of x, again, x, times g prime of x. So g of x was x squared minus 1, and we'll prime it. And then we'll put g of x and square that. So g of x was x squared minus 1, and we'll square the denominator. All right, so now we have y prime is equal to, so x squared minus 1, and the derivative of x is just 1, so we'll leave it at that, minus, and the derivative, we'll multiply x, the derivative of x squared minus 1 is just 2x. So now we put that over x squared minus 1 squared, and we'll continue further down below here. Y prime is equal to x squared minus 1, and x times 2x is going to give us negative 2x squared. So now we have that over x squared minus 1 squared. I know there's a lot, but bear with me here. Y prime is equal to, so x squared, we'll combine the like terms. We have x squared minus 2x squared is negative x squared. And then we're left with the minus 1 over x squared minus 1 squared. And this, ladies and gentlemen, is our final answer. Here we have our next equation. We have y equals to 1 over 2x cubed minus 6x squared plus 5. So our f of x is just simply 1. And our g of x is going to equal 2x cubed minus 6x squared plus 5. Okay, so using the quotient rule, I like to always rewrite it. G of x times f prime of x minus f of x times g prime of x over g of x squared. We'll just put it that way. And we'll continue with the y prime. We'll continue with the rule here. Y prime is equal to g of x first. So we have 2x cubed minus 6x squared plus 5. So I'm wondering if I will have space here. I probably will. Times 1 prime minus 1 times 2x cubed minus 6x squared plus 5 prime, and then have that over the g of x squared, which is 2x cubed minus 6x squared plus 5 prime, or squared, I should say. So now in the top, we can see we have y prime, and the derivative of a number, so over here where I'm squaring, that is always going to be 0. So the derivative of any number is 0. So we're going to have 0 times this left parentheses. So 0 times anything is always going to be 0. So we're left with just negative 1. We're left with this blue part here. I'll rectangle here. I'll circle it here. We have negative 1 times 2x cubed minus 6x squared plus 5 prime. So let's go ahead and take that derivative first. So we're going to have negative 1 times, well, let me write that. We're going to have negative 1 times derivative of 2x cubed minus 6x squared plus 5, and that's going to be 6x squared minus 12x. And then we're obviously left with the denominator. Don't ever forget the denominator. All right, so in the denominator, we're going to have 2x cubed minus 6x squared plus 5 squared. All right, so all we're doing in the numerator is changing the signs of the terms. When we multiply by negative 1, we're going to have negative 6x squared plus 12x over 2x cubed minus 6x squared plus 5 squared. And this, ladies and gentlemen, is our final answer. We could also, looks like we could factor out, depending on what the, I mean, in this problem, you don't have to factor anything out, but let's say we want to simplify it a little bit more or factor out the common or the greatest common factor here in the top of the numerator, which is going to be, you can factor out a negative 6x if you want, negative 6x. So we'll be left with x over here and then minus 2. And then parentheses, and we'll get 2x cubed. Of course, don't ever forget the denominator, minus 6x squared plus 5, and then square that. And this could be your answer as well. All right, let's do this last one. So, of course, there's two functions being divided. So, again, we need to use the quotient rule here. We have g of x times f prime of x minus f of x times g prime of x over g of x squared. All right, so our f of x is going to be x squared, and our g of x is going to be 1 plus x. So now all we have to do is substitute those into the rule, and we have g of x, so we have 1 plus x times f prime of x, so that's going to be x squared prime minus x squared times g prime of x, so our g of x was 1 plus x, and we're going to prime that. and then over g of x squared. So we have 1 plus x squared in the denominator. And of course, as always, I always forget to prime the x squared or prime something, but there it is. So we're going to have y prime is equal to 1 plus x, and the derivative of x squared is 2x minus x squared, and the derivative of 1 plus x is going to be just 1, and then over 1 plus x squared, or I should say squared on the outside there. Okay. Oh, that's a lot. We've done a lot of problems so far today, and I'm getting a little tired, but we're going to continue here. Y prime is equal to, we'll distribute the 2x, so we're going to have 2x squared plus 2x minus x squared over 1 plus x squared. And we'll combine like terms, so we're left with y prime is equal to x squared plus 2x over 1 plus x, and then square that. And you could leave this as your answer, or you could factor out the what's common in the numerator, which is the x, and we will have x times x plus 2 over 1 plus x, and we square that. And this could also be your answer. All right, so that was some examples using the product and quotient rule. There are a lot more, and trust me, those aren't the only videos or problems I'm going to do and make a video of. There are countless more that I would like to do a video on, especially those that involve the exponential function derivatives using the product rules and the quotient rule. So it's going to be a lot more videos out there. If you want me to do a short or a video on one particular problem, you can leave that in the comment section down below. But if you enjoyed this video, give this video a like, subscribe to my channel, see more videos like this, and hit that notification bell button down below to be notified when the next video is up. And I'll see you guys in the next one.